This is my milling machine that we did the mill updates videos on, so this is going to be a part 4. I've not been on YouTube for a while because I've been mainly posting to Instagram, mainly because of the time it takes to edit the videos, and I also have my PC down for a good while, so I'm hoping to do a few more videos and show you guys where I'm at. So this is the machine that we started off with. It used to have hand wheels. It's a Geo 704 style machine. I'm in the UK, so it's a UK machine. So you can see it's changed quite a lot since we last looked at it. It's now got the full enclosure. So I've made a sill enclosure for it, and it's all aluminium lined. So one of the last things I showed on my Instagram was these covers that I did. I also had them on the Y-axis as well. They worked pretty good at first. Eventually they got a bit clogged with chips, and sometimes they get a bit rickety. The Z's been pretty good. So on the spindle end here, I've got my cap, which stops the original quill from coming down. So that's just bolted in. I've got some big bolts up in there, and it also acts as a coolant manifold. So I've got my coolant coming from the back of the machine and comes down this nozzle. At the moment I'm just adjusting it based on where I need it using this tie wrap. But we get a pretty good coolant flow through there. I've also got another nozzle on the other side if I need it, if I need two nozzles. I'm currently using the TTS tooling system. So I've got quite a few tools now, and we've got the power drawbar that I designed, and we built on this mill. So it's a bit different to what some other people have done. This is a 2-stage cylinder. I believe I did it about 100mm cylinders in each stage. So we've got one stage here, the other stage here, which are common together. This bottom one is actually a through spindle unit that I made. So there's a O-ring in there, a double wall seal that seals to the top of the drawbar tube, so I can spit either coolant or air straight through the spindle. What I discovered with the Tormac tooling system, because there's no pull stud through spindle coolant, obviously weakens the bond there, so it's better to use air. So I'm going to use air for my tool changer, and as you can see around the back, we've got some pipes back here. So there's no commoning on the outside, it's all done on the inside of the block, so I've cross drilled holes through it. And the motor is also mounted on the side now. Originally the motor was up on the top, so I've mounted it on the side. This gave me more clearance in the old mill location, and it keeps the weight lower down. So I've done a bit of a pulley system here. So we've got a 2-to-1 and a 1-to-2 gear, so we can swap it either way around. So I can get up to like 4,000 RPM, although I tend to stick around 2,500 for most things. At the back here we've got the automatic oiling system. So we have an oiling tub. On this side is regular oil. Transfer pump pumps through that manifold down to all the pipes under the table, which come in through the original gib locking locations. As well as we've got some more on this side. It's quite tight in here, so I'm trying my best to get the camera in. So at the moment that's just on a couple of leads that I hook on. Every time I home the machine, it just feeds a little bit of oil to everything as it moves along. So here's the other side of the enclosure. See, it's a big wrap round piece of steel. And here's my control panel that I built. So I'll move around the front. So here's the control panel. We're running Linux CNC. found Linux CNC pretty good overall. I was originally going to use the Mac 3 or Mac 4. I had a lot of recommendations to use Linux CNC, and it has been a good choice. It's been very stable. I know some people suffer with Windows updates and things messing stuff up. Linux has been pretty stable for me. I'm not connected to the internet with this machine for that reason, just so nothing messes up. But yeah, it's been really good. The Linux programming side's been a bit of a learning curve for adding some of the tool changing parts on, because I'm developing the tool changer for this, side mount tool changer, which is going to live under this side, and it's going to drop a tool down and feed it over with 18 tools. So going back to the panel, I machined all this, and the green light, which is obviously the on light, this is for the spindle running. So I've just took the signal from the original driver box, which this is also from, these controls. So originally the driver box was on the side of the head over here, so I've just pinched the signal from that, and that shows me any time the spindle's running. So if I turn the spindle on, you can see the green light is now running, and I can also turn the spindle on and off here through my keypad. You can see when it's on, it's on. When it's off, it's off. And the yellow light is my pause light. I don't think it will work at this time. I think it'll only work when the program's running. Yeah. And the red up there is because I turned on my bypass so I can run with the doors open. So around here I've got some extra switches. So this middle one is my bypass. So if I turn it off, you'll see that safety light turns off. So that's the normal state of the machine, where it won't turn the spindle on with the doors running, even if I tell it to. As soon as the door's shut, the spindle will then be allowed to run again. So that's just done off a couple of switches. Just about to see them here. So there's one on each side, and that gets triggered by the door. Hear a little click. So that's how I've done that. So this whole keypad, I've also got the buttons here, obviously the go, the pause and the stop. And the rest of it I did a full keyboard, because I found that using these regular keyboards tend to get jammed up with bits of metal and swarf. And then I had a few occasions where the machine was crashing because of that. So I did the full keyboard on here. I machined all the caps, engraved all the caps. Looking back, I should have done engraving maybe slightly deeper. It might have contrasted a bit better, but overall works pretty nicely. Yeah, so I've got the full keyboard here with all the letters, or most of the letters I should say. The X, Y and Z I've moved here for convenience, and the F for feed rate, so if I need to just punch in some quick bit of manual code, I can do it here without having to use the bottom keypad section. And then up here we've got some more of the other keyboard shortcuts functions. So this whole panel is treated like a keyboard. It's done through an arcade machine style keyboard input device. So you wire any kind of button up to it, you program the terminal for wherever you plug that wire into to tell it what you want it to do. So for the A button would have gone into one of the terminals on the arcade machine driver. I'd have then gone in and programmed it and told it that's an A, and that's a B, that's a C, and so on. So some of these are just combination keys for shortcuts, so I can switch between the different modes, like the MDI mode, back to the manual mode. We've got some that I'm not using yet. So we've got flood, air, and we've got a couple of spindle control buttons like I've already shown. X, Y and Z repeated here as well as touch off for my probe. These three I've not programmed yet. I just left them as like optional kind of expansion when I want to expand stuff. Here I've got USB slots which come in really handy, instead of having to reach down to the PC, which at the moment is down here. PC and the driver box. So it's really handy to reach in here instead. So at the top I've got my main breaker that turns off everything. These I haven't attached or anything yet, so they're just extra buttons when I want to add extra functions. So I might put my oiler on that eventually and wire these into the 12 volt supply. That's something I've not got around to doing yet. So the original spindle controls, so obviously you've got your speed and you've got your direction, as well as the RPM feed, RPM readout, and equally I can override it, so I can manually turn the spindle on and off if I choose to. If I leave it in the central position, then none of the contacts are closed, so it won't move, but then it allows the PC to close the contact. So I've got a set of relays in here that close either clockwise or counterclockwise. I've got a few more switches down here on the back. We've got a fan which I need to fix. I noticed the other day it stopped, and a lot of the wiring comes out the back. Obviously you've got the heatsink for the original speed controller. On top we've got a couple more fans, so they're both working. They suck the air up. We've just got the mouse for now, which I'd like to get away from, but it's still quite handy. So this rear fan would draw the air in, and the top ones would blow it out, so any heat rising would just get straight out of the cabinet. This whole thing stays fairly cool. This screen's just a PC screen that I put in there, and some of these lights will be attached to some of the buttons at a later date. So that's the overall outside of the machine. I've recently welded up this frame which holds the top steel part to the bottom section of the desk. Originally it had a laminated piece of wood, and this eventually got coolant on it and went a bit kind of mouldy. The bottom section of the desk is a steel desk that I bought. Unfortunately some of the bottom bit did twist when I tried to move the machine, so I've had to do what I can now just to rigidify it again. But that'll be sorted at a later date. So this top part normally has my cutters in. I did have a bit of a coolant leak, so I stopped with that. And the rest we've got a few bits of tools that still need sorting out and arranging. Down there we've got the foot pedal. So that's a pneumatic pedal for doing the tools. So we can take each of the tools out of the spindle. And here we've got the coolant. So with the new steel part that I made, it's a big trough. I did clean some of the machine, but I left some of it natural. Just we've been doing a lot of milling recently. So this slopes down and pushes anything under the mill, so the mill's actually up on some bits of steel you can't really see, but there's quite a big cavity under there. And then here is the hole where everything passes down into that bucket, but all the sides are angled. I learned that quite quickly, that stuff will build up if it's not angled, so you want angled sides. So down here we've got the bucket with the coolant, and first we strain it. So I've got like a regular 10 litre bucket with some holes in it. I believe there's two stacked on top of each other with some fabric in between just to catch any fines. It does a pretty good job. And then the bottom bucket is just for the liquid, and we've got a pump which pumps up this hose around the back of the machine, and that's what this is here. Obviously missing some fittings, but it's working pretty good for now. And we've also got limit switches on all the axes, which work pretty well. See, the other one is down here under the table, and then the back one is hiding away down here somewhere. But yeah, they're the recent improvements that I've made. I've got my dual station vise, which I love. It works really well. The only kind of gripe about it is this little metal bit, which is supposed to be in the centre. It stops these covers from sliding, but it has bent over time with me moving things around, so it's a bit tricky to get it under here now, so I might have to address that soon. But otherwise it's pretty good vice. The dual station feature I've not really used much. I bought it mainly for the wide capacity, because you can take this middle section out and you can grip like from here to here. You can grip quite a wide range, and that's just clamped down on the vice body at the moment. Probably need to make some clamps to hold on this edge, but it's quite a small edge. It makes it a bit difficult to keep setting it up, because the clamps have to be very specifically on there. You've only got about 4mm edge, and I don't want to ding this label up either, so I just choose most of the time just to clamp anywhere I can to hold that thing down. I've recently swapped out the lights, so I've got a light here. I had a similar one on this side that I've just swapped out to a bigger one because the other one had died, but that gives me a decent amount of light in there. Up here I've got my lists that I sometimes use. So these are just my notes, so that's how we do the tool change, because I've rewrote the tool change routine. How I use the probe for the table so I can measure tool lengths. Then it's just a quick checklist that I wrote. Is it the correct program? Is it correct cutter in and tight? Is the workpiece rigid and tightened in the vise? Is the part touched off in X, Y and Z? Do we need any spoil board so we don't damage the bed? Does the machining fit within the machining travel? So they're just my notes that I sometimes refer to. I try to refer to every time I run a job, especially when it's a new job, or something I'm setting back up again. So at the moment I've just got these rubber covers at the bottom. I did originally have the metal sliders. They got really bent up on this bottom one. Obviously gravity shoves chips down in there, whereas the Z1 tends to stay more clean. And that's what I've got so far really. I've also got table probe. I did a short video on this. Like I said, I've been sharing a lot more on Instagram than YouTube. I was doing loads of videos originally. My computer died and then I couldn't edit videos or do anything with my files, so I thought Instagram was a quicker way to upload, so that's what I've been doing for a good while. But I'm hoping to bring back some more videos if people are interested in seeing it. Yeah, so this is my table probe. So this is another one of them switches, but I've modified it to remove the crash protection, because within here there's a small amount of slop on the top, which allows it to be whacked pretty hard, and that slot will be taken up before it actually gets the internal mechanism. So I've taken that out, so that was just a spring. I've replaced it with a bushing that I had to make on the lathe, a brass bushing of the same size. So now there's no slop in it whatsoever, or none that I can measure anyway. As I did in my video, the repeatability of this is as good as what we're getting on the control here. It came up as the same numbers every single time. Every time it was 0.000 after 3 or 4 tests. And I also proved my spindle, my Z, was relatively accurate. So this probe is a really good way to check the tools and set the tool heights. So that's been a really good improvement from originally setting up tools just manually, having to touch on top of the material. This saves a lot of time. It's really useful, and I'm definitely going to fit a probe to my next machines. So this machine is my original mill. Since then I've got 2 more mills that I need to CNC, 2 more slightly smaller ones. We've also got the lathe, the pick and place. I've got another robot and a small little router that I'm building. And I've recently started building a big mill, a lot bigger than this, because I'm looking to upgrade to a proper machining centre style of mill, just for that rigidity, mainly rigidity, and secondly table area. You don't get much table area on these mills. It's decent enough when you're first starting out and making parts. You can reclamp parts in different orientations and try and match it up, but I'm looking for a bigger mill that can do some of my hobby stuff as well. So it can do some engine work and bits like that as well. So I'm going to probably show that in a later video. So I'm building something that's similar to the Haas machines, or that kind of level. So I'm starting with big bits of cast iron and building up that way. Instead of this being a mill that's quite high off the floor, you get a lot of vibrations. So my new mill, I'm building it off the floor as a big piece of cast iron, and I'm going to build chip systems and that around it. So that's just a quick update on my mill and where we're at. I think I've covered everything, so if there's anything else you'd like to see, let me know. These doors are 10mm thick polycarbonate, just to stop anything flying off. Obviously I've seen some nasty videos of vice parallels flying out of the windows and smashing windows and stuff, so that's one of the things I also did. But yeah, that's it. Thanks for watching. Please leave a comment, like and share my videos, and let me know if you want to see anything else. Thank you.